Hello, in this video I'm going to talk about how to use the Selkie GAD-CFD tool and what support is available around the tool. And before we start, I would like to say that this tool is very easy to get hold of, very easy to install on your computer, and very easy to start creating your own cases and simulations. And you're very welcome to download this tool and start using it. So this is the address of the repository where the code is stored. And if you put it into your browser, it should take you to the login page of the repository. We do have some plans to make this repository publicly available, by which point you won't need an account to access the code. But at the moment, I'm afraid if you would like to start using it, you will have to sign up. But it's a relatively simple process, and we will talk about that in a moment. The repository is hosted on GitLab, which is a very powerful platform for software development and distribution. It allows different developers to work on the same project in parallel and then automatically merge the work they built together. It also keeps a record of the old versions of the tool and all the associated changes. So if you would like to go back to a previous version because you liked some of the old features, it's very easy to do that. So now let's go to the websites and find out how it works. So I have to stop sharing the slides and start sharing my web browser. And here we go. So this is the login page of the repository. Because I already have an account, I'll just log in a moment. So if you would like to sign up, you just have to click on the register button and then fill in these 5 boxes. There's no extra information required. And then click on register, and we will be able to pick up your request and give you access to the repository. So let me just log in. Okay, so this is the overview page of the repository, and normally this is where you would arrive at each time you log into the repository. It's got 2 folders where the code is stored, a couple of license files stating the terms and conditions of using the tool, and a README file which is quite nicely formatted and presented. It's got a very brief introduction of what the tool does, what it is and what it does, a couple of open access journal papers the tool is based on, and a pseudocode of the model, which can help you understand the structure of the code if you would like to dig into the code itself. It's also got some computer configuration requirements for you to be able to download and install the tool onto your computer. So if your operating system is Linux, then that's great. You can start straight away by following the installation guide to install the tool onto your computer. And then we will talk about the installation guide in a moment. But if your operating system is Windows, then you will have to follow these instructions here to download and install the Windows subsystem for Linux and Ubuntu to create a Linux environment onto your Windows machine. Once you've done that, you can then follow the same instructions to install the tool under the Linux environment. If you come across any problems and issues, you're very welcome to use the issue tracker to leave a comment. So the people who have access to the repository will then be able to see your comments and respond to it. The other button, the other page that's quite important in the repository is the wiki pages. So if you click on wiki, it will take you here, and you can see that there are 5 pages in the wiki. The model overview page is very similar to the introduction page we just went through. It's got a very general overview of the functionalities of the tool. The GAD-CFD model page, the second page, then has got the math and theories behind the tool. So once you've gone through this page, you will have a fairly good idea of what the BEM model is. Basically, the BEM model is the core of this tool. You will also be able to find out what modifications we've done so far based on the BEM model to improve the accuracy of the model in terms of predicting power output as well as wake dynamics. We also provide some lift and drag coefficient lookup tables as a function of Reynolds number and angle of attack for a selection of aerofoils. And you can find the details of these lookup tables on the aerofoil characteristics page. Here we won't talk about the details. The installation guide can be found on the installation guide page, obviously. So it's very simple. All you need to do is to download this script, which helps you to set up the necessary environment to install the tool onto your computer. Once you've done that, you can then follow instructions, basically copy and paste. This highlights the comments into your terminal and run them using the Enter key on your keyboard. The most important thing is to run them in the right order. Apart from the installation instructions, we've also provided a test case for you to test whether the tool has been installed onto your computer properly. So if you click on this link, it will take you to a OneDrive storage space to download the test case. So the test case is stored in the second folder. The first folder also stores the results that you would get if the tool was installed onto your computer properly, so you can do a comparison afterwards to make sure that the installation went well. Okay, so the user guide then gives you some instructions of how to run the test case. Again, it's very simple. All you need to do is to copy and paste and run this command in your terminal. So the first block of the commands are for single thread simulations, and the second block of the command is for parallel simulations. Once you're familiar with these commands, you can actually modify them slightly to make them suitable for your own cases and simulations. This page also tells you what files you will need to create your own cases and simulations using the GAD-CFD model. So here is the structure of the files. It also links you to the relevant sections of the official OpenFOAM documentation to find out the details of these files. So for example, if you would like to find out what the block mesh dict file works, so this file defines the dictionary for block mesh generation. All you need to do is to go to section 5.3 of the OpenFOAM documentation. You can find it. You can click on this link and go to the documentation. So let's click on section 5.3. So here we go. So here you will be able to see that it talks about what's in the file in a great detail and explains what each of the variables means. Once you've understood that, you can then modify the file according to your own cases. So yeah, it's the same for all the other files. And if you scroll further down, here, I think this part of the instruction is relevant to the bits we added to the OpenFOAM, which is used to simulate turbines. I think that's everything. I hope you found that helpful.